Hi everyone, in this video we will discuss another sorting technique which is selection sort. Okay, so here on the board you can see I have written down the algorithm of selection sort and I have taken an example as well. I will be applying this algorithm on this example to properly understand the concept of selection sort. Okay, so now let us first have a little bit of discussion on the concept of selection sort. Okay, so now here you can see I have taken an array and this array is completely unsorted. Okay, so now in selection sort what we will first do is we will consider the first element as the smallest element. Then from this smallest element we will keep on visiting each and every index of this array by comparing. Okay, so now suppose I have started from this index, first index, by considering this element as the smallest element, then we will move on to the second element and then we compare whether 10 is smaller than 25. Okay, suppose we have considered this as the smallest element, then we will make a comparison between second element with the first element. So now since 10 is less than 25, so what I will do, I will mark second element as the minimum element. Then I will further check in this entire array, is there any element present in this array which is lesser than the second element. So for that what I will do, I will compare third element with the second element. Okay, so now 72 is not less than 10. Okay, now let me just consider this as 9. Okay, 72 is not less than 10, so we will keep the minimum element as it is and then we will move on to the next element here. Okay, then we will compare the fourth element with the second element. Since 18 is not less than 10, so what we will do, we will further move to the next element to check whether this last element is lesser than the element. So now when we visit to the last element and make a comparison between the fifth element and the second element, we come to know that this element is lesser than the second element. So what we will do, we will mark this element as the minimum element. So now we come to know that in this entire list we have the last element as the minimum element. Okay, so what we will do, when we find out the smallest element in the list, so we will swap this 9 with 25. Okay, so what we will do, we will put 25 here and we will put 9 here. Okay, so whenever we find out the smallest element in the list, then we will swap that smallest element with the element from where we had started searching the smallest element. So this is the place where we had started searching the smallest element. That's why we have make a swap between the smallest element and this element. Okay, so I'm sure you guys have understood. Okay, so the same process we will be going to follow by using this algorithm. Okay, so now let me just change it to 40. Okay, and now this will also 40, this will be 25. Okay, so now let us start applying this algorithm on this example. Okay, so now let me just consider this as a step 1. Okay, so now in this algorithm you can clearly see the first for loop started from I equals to 1 to 5 because I have 5 elements. That's why the for loop gets started from 1 to 5. Okay, so now I value is 1, for I value is 1, and that is the first step. Okay, so now let me just write it here, I equals to 1. Okay, then I will initialize the value of I to min. That the value of I is 1, so I will pass the value of 1 to min. That means I am considering this first element as the minimum element. Okay, then next I will come to the for loop to run this for loop from j equals to I plus 1. I was 1, so I plus 1 becomes 2. 2 to 5. This for loop gets run from 2 to 5. That is from this index to last index or final index. Okay, so now j is points to second index. Okay, so now next we will make a comparison between the second element with the first element as I have explained you just few minutes back. Okay, so now j will be pointing to the second element. Okay, and we have pointed minimum to the first index. So what we will do, we will make a comparison between the second element with the first element. So now a of j is less than a of minimum, so a of 2 is a of j is second element. So now 10 is less than 25. Yes, since 10 is less than 25, condition becomes true. Then we will pass the value of j to min. That means we are changing the minimum element to the second element. Since j is equals to 2, now j was pointing to second element. So now when condition becomes true, we will start pointing this minimum element to the second element. Okay, so now min gets initialized with the value of 2. That means now minimum will be pointing to the second element, and then once we come out from this if statement and we have to run this j till 5. Okay, now j gets incremented by 1. So now earlierly j was 2 and now it becomes 3. So now j will be pointing to third index. Okay, and now we will make a comparison between the third element, which is this third element, with the second element. Now we will check whether 72 is less than 10. Okay, yes, 72 is not less than 10, so condition becomes false. So in this case we will not change min, we will not pass the value of j to min because condition didn't get satisfied. So we will just come out from this if and return to this for loop to increment the value of j from 3 to 4. Okay, so now we will just come here and 40. Okay, so now minimum element will be 10 only. So we are just changing the position of j. Now j will be pointing to 4. Now we will make a comparison between 18 and 10. Okay, so whether 10 is 18 is less than 10. Now 18 is not less than 10, so condition becomes false. So here you can see this condition becomes false. So again we will not change the min location with the value of j. So we will come out from this if and again we will increment j by 1. So earlierly j was 4, now j becomes 5. Okay, let me just write down here 40. Okay, now minimum element will be 10 only, and since j gets incremented, so j will point to last element to make a comparison between the last element with the minimum element. Now again we will make a comparison here whether a of 5 is less than a of 2. Okay, so now 40 is less than 10. No, so we will come, this statement will not get executed. Then we will come out from this end if, and this for loop has reached to the last index 5, because this for loop j will be iterating from second to fifth. Since we have reached to the fifth index, so we cannot further increment the value of j. So now here you can see, since this condition becomes false and we have reached to the last index, which is the fifth index, and after reaching to the fifth index we didn't find an element which is lesser than this minimum element. So that means this is our minimum element. So we will mark this element as the minimum element, and what I had told you, whenever we find a minimum element in the entire array, we have to replace that smallest element with the element from where we had started searching the smallest element. Okay, so we had started searching the smallest element from this first element, so we have to replace this 25 with 10. Okay, so now 10 will come here, 25 will come here, and 72 will come here, 18 and 40. Okay, so now this swapping will be done with this swap function. Okay, so now let me just do this as well. Okay, so a of I equals to t. Okay, so now initially I was 1. Okay, and a of I is 25. Okay, so now according to this t becomes 25. Okay, and then a of I in the first location we will be swapping the a of minimum. Okay, so minimum, we come to know that the 10 is the minimum or the smallest element, so we'll pass this smallest element to I, which is 1, first index of array A here. Okay, 10. Okay, we'll pass 10 in the first index of this array, and then a of minimum, that is in this location, in the second location we will pass the value of 25, which is t. Okay, t holding the value of 25, and we will pass that 25 in the second location. Okay, where we had come to know that in this place we had the minimum element. Okay, so now you can see by applying this algorithm we have completed the first step, and we come to know that the 10 is the smallest element, so we have brought that smallest element into its sorted position. Okay, so now you can clearly see this array has been divided into two arrays, left array and right array, where left array is completely sorted and right array is not sorted. So we have to apply the same selection sort algorithm on this right unsorted array to find out the smallest element in this unsorted array. Okay, so now let me just do the same process on this. Okay, so now let me just bring these numbers here, 40. Okay, so now this is step 2, and now for this step 2, I is 2. Okay, so now once I reaches to the last index, that is 5 in the first step, again we will come out from this for loop and increment the value of I. Now I becomes 2. Okay, so now when we follow this algorithm, so now you can see I is pointing to min. That means the value of 2 is initialized to the min. So now this second element is been considered as the minimum element or the smallest element. In the next step, we have a for loop with j. Okay, so now j equals to I plus 1. I was 2, so j equals to 2 plus 1, which equals to 3. That means j will be pointing to third index. Okay, so now we need to make a comparison between this third index and the second index. Okay, so now let us do that. 72 is less than 25. 72 is less than 25. No, 72 is not less than 25, so this condition becomes false. So in this case, this statement will not executed. We will come out from this if, and while coming out, we will increment the value of j by 1. So j was 3 in the last case, so now j becomes 4. Okay, so now let me just write down these numbers. 40. Okay, so now this was our minimum element. Okay, since j is incremented by 1, so now in the last case j was 3, but in this case j becomes the fourth element. Okay, so now we will make a comparison between the fourth element with the second element. Okay, so now 18 is less than 25. Yes, 18 is less than 25. Condition true. This condition becomes true. In that case, this statement will get executed. Now the value of min gets changed. Okay, the value of j was 4 in this case, so the 4 gets passed to the min to make the minimum element as the fourth index. Okay, so let me just write down these numbers. 40. Okay, so now the fourth element becomes the smallest element, and while coming out from this if condition, j will get incremented by 1. So j was 4. Now since j gets incremented, it becomes fifth. Okay, so j will be pointing to the fifth element. To make a comparison between the fifth element and the fourth element, we will check whether 40 is less than 18. No, 40 is not less than 18, so condition becomes false. So when condition becomes false, this statement will not get executed, and we will come out from this if. We cannot further move ahead because fifth is the last index in this array. So at this step, we will come to know that 18 is the smallest element out of these 4 elements in this right array. Okay, so now what I have told you, when we find the smallest element in the array, we have to swap this smallest element with the element from where we had started searching the smallest element. So we had started searching the smallest element from this point, so we have to swap this 18 with this 25. Okay, so now here 10, okay, and here 18, and then you need to put 25 here, 72 here, and then 40 here. Okay, so now let us see the swapping process. Okay, so now a of I was 2. Okay, so a of I is 25. Okay, so now t will be 25. Okay, and then in the place of a of I, that is in the second index, which is this position, we will pass the a of min. Min, we calculated that this element is the minimal or smallest element, so we will pass this smallest element a of min, which is this element. We will pass this element to the a of I. Okay, in the second, I is 2, so we will pass this minimum element in the second position, and then at the end we will pass this one, okay, which is 25 in the position of minimum, where we find the minimum element. Okay, so now you can see clearly we have found the second smallest element. Okay, now you can see the left array is completely sorted, where we have 10 and 18, and the right array is not sorted, which is unsorted array, and we have to apply the same selection sort approach on this right array by following this algorithm. Okay, so now this will become our step 3. Step 3, and for this step I becomes 3. Okay, so now since I gets incremented, okay, after j in the last step we had reached to the fifth index, and when we coming out from this for loop, I gets incremented by 1. So now I becomes 3. So I equals to 3. That means 3 will get passed to minimum. So now our minimum element will be third element. Okay, so now we have considered the minimum element as the third element, and from this point we have to start searching in this complete array. Is there any element present in this right unsorted array which is lesser than 72? We have to check that. Okay, so for that, as I have said, we have marked the third index to the minimum. That means we have considered the third index element is the smallest element, and then we will consider another for loop starting from j equals to I plus 1. So I is 3, so I plus 1 is 4. Okay, now the fourth index becomes the j. So now we need to make a comparison between the fourth element and the third element. So that's what we are doing here. A of 4 is less than A of 3, that is 25 is less than 25 is less than 72. Yes, condition true. 25 is less than 72. So this becomes true. So when this condition becomes true, this statement gets executed, and now we are passing the value of j, that is 4, to minimum. That means we are considering that this fourth element is the minimum element. 10, 18, okay, 72 and 25, 40. So we'll mark this element as the minimum element. Okay, and when coming out from this if condition, the j gets incremented by 1. So now j becomes 5. Okay, this is our j. Now we will make a comparison between the fifth element and the fourth element. We will check whether a of j, which is 40, is less than a of min, which is 25. So 40 is less than 25. No. 40 is less than 25. No, 40 is not less than 25. This condition becomes false. When this condition becomes false, this statement will not get executed and will come out from this if. So we cannot further increment the value of j because that is the last index in that array. So we come to know that the element present in the fourth index is the smallest element. Okay, so now we have to swap this 25 with the element from where we had started searching the smallest element. So this is the place we had started searching the smallest element. So we will swap 25 with 72. Okay, 25 will come here and 72 will come here, and then 40, then 10, 18. Okay, so now you can see our left array is further gets sorted with the elements 10, 18 and 25, and on the right array we have unsorted elements which is still to be sorted. Okay, 72 and 40. So next, yes, here you can see I can also do this swapping. So now t is equals to a of I. I was 3 in this step, so a of I is a of 3, which is 72. 72 will come here, and then a of I in the place of 3, we will pass the value of, so that is in the place of this 72 we will pass this a of minimum. So a of minimum, min, we found that this element is the minimum or the smallest element. We will pass this in this position, that is 25, and then next is a of min. Yes, in the location where we found the smallest element, that is this location, we will pass the 72. Okay, so that's how we swap the elements. Okay, now the next what we will do the last step, which is step 4, and in this step 4 I becomes 4. Okay, yes, once coming out from this for loop, inner for loop, this control will come to this for loop to increment the value of I from 3 to 4. Okay, so now I becomes 4. So for the value of I equals to 4, we have to run this algorithm. Okay, so now 4 gets passed to minimum. That means this element 4, fourth element, will be considered as the minimum element, and then we will run an inner for loop with j, where j has the value of I plus 1. I was 4, so I plus 1 becomes 5. So this fifth index becomes j. Then we will make comparison between a of j and a of min. A of j is fifth index and a of min is fourth index. We will compare both of these elements, whether 40 is less than 72, 40 is less than 72? Yes. 40 is less than 72. Condition true. When condition becomes true, this statement gets executed where we will pass this j or the value of j to min. So now this last element will become the minimum element. Okay. Okay. So let me just write down here 10, 18, 25, 72 and 40. Okay. So in this case, in this step, m was pointing to fourth. Now since condition gets satisfied, that's why the value of min becomes changed. The value of min gets changed. So j value was 5. 5 gets passed to minimum. So this will become minimum. So we have found out the smallest element out of these two elements. So when we find the smallest element, we have to swap the smallest element with the element from where we had started searching the smallest element. So now we had started searching the smallest element from this point. So we will replace 40 here and we will put 72 here. 10, 18, 25, 40, 72. Okay, so now at the end you can see we got the sorted array with the elements 10, 18, 25, 40 and 72 by applying this selection sort technique, okay, using this selection sort algorithm. Okay, so now I'm sure you guys have understood the working of selection sort. So in this video we have taken the algorithm and according to the algorithm I have tried to solve this unsorted array to make it as sorted. Okay, so I'm sure you guys have understood the complete process of or working of selection sort. Okay, and that's all for this video guys, and thanks for watching.